practice recording. Yeah, here we go. So this is a second take, but you didn't need to know that. So this is your boy Abdul, aka the Smog Juice Man, back at it again with another one. And to kick this off, I wanted to no, no, I'm gonna be conscious about this. I have decided to focus on this series, if you will, in the pursuit of having a healthy understanding of mathematics, being able to solve certain types of problems of varying complexities, and adopting the mindset of a problem solver and a mathematician, which I believe, given the certain scenarios, can be pretty synonymous. And I can most definitely explain what I mean by that as the series progresses and as this video in particular progresses. So, what I am focusing on for today's video is the idea around problem solving and its applications. And to start, I would like to focus on the following, no pun intended. So, to begin, I believe in this setting, we must define the term problem solving. And how I would define what problem solving is to me is having the conscious understanding that for every problem, there is at least one solution. To play devil's advocate, one might say that depending on the type of problem, sometimes there may not be a solution. And to that I say, yes, you are correct, but that is still considered a solution. If no solution is still considered a solution, right? You hear people say that doing nothing is still doing something, right? So I believe this statement holds truth in that the paradigm of problem solution in the world of problem solution, there is a sense of duality where that there is, based on the preconceived notions of what people believe to be a separation between the two, there really is a sense of duality between the two where one can't necessarily exist without the other. And the reverse is true. You could also say that for every solution, there is an association to a particular problem. So without rambling too much, I am showing you this example to get a picture as to when we get into more deeper and more complex problems, to adopt this mindset of recognizing that for any type of situation, there always is going to be a problem that you are faced to solve. So think of this as me planting a seed in your head. So we have that out of the way where we've defined, um, based on your own definition, if you will, what a problem is or a solution is in terms of its existence. We've defined that for there to be a problem, there has to be some type of solution, and acknowledging and appreciating this existence. So then the question is, um, what is a problem? A problem can come in the form of addressing an issue of efficiency in terms of finding a finite answer to a question. It could also mean finding an alternative to a methodology that is no longer feasible, or a type of way that isn't sustainable, right? So it can be in the form of finding or seeking out an alternative. And we see this in different types of examples of problems where we're dealing with instance, you were designing a boat and you were trying to figure out whether or not the material of the boat plays a role in terms of its efficiency, the type of motor that is being used in the boat has something to do with whether or not it answers your question of efficiency, or the type of sail that you're using answers the question, or operating in weather has to do with the question of efficiency. In terms of answering the question, it's whether or not you like pineapple on pizza, and it's yes or no. That's solving a particular problem, which can be in the form of a question. You see what I'm saying? Or it's asking you to combine different types of values to output one type of value. So, not gonna go too deep into that, but just again, like I said before, planting seeds in your head to address the idea of problem solving as a concept and to get a somewhat palatable understanding of what that means to solve problems or look for problems to solve, or as I get to the next point, defining types of problems. So once we've defined the existence of a particular problem we're trying to solve and acknowledge its existence and recognize for what is going on, usually when we say that, we're talking about what is currently happening right now. Like, oh, there's a leak. Okay. Next would be then to analyze the problem. Okay, cool. There's a leak. What about it? What's going on that is causing a leak to happen? Where are you currently right now that you are seeing this type of situation taking place? Is there a leak going on in your bathtub? Right? Is there like a little leak coming out and there's like a pool of water? Or there's some tubing inside your house and there's water dripping and then it's dripping around your ceiling. This is not really a perfect design, but you get the drift. But when I say analyzing a problem or being analytical to a problem, or just being analytical in general, you're no longer just accepting that there is a problem and in the back of your head accepting that there is a particular solution to the problem. You are then looking at the leak and taking a deeper dive as to what's actually going on. You're looking at the materials, right? In terms of this type of situation, you're looking at the materials. Do they play a factor? What about the utility or the usage of said objects or materials and whatnot? Are we looking at something that has not been taken into account for, so some other miscellaneous variables? Maybe there is a neighborhood-wide issue with the piping system and there is a lack of water, or there is a surplus of water coming into your piping, which allowed for the piping, hypothetically speaking, to burst from the mass of water. It's just a hypothetical. So just keeping into account the different types of variables that we don't tend to look at first glance. What's being used, or what caused the certain types of things to be affected, and just the materials in and of themselves. Based on this particular type of situation, of course, when it comes to analyzing the problem, the types of what we call parameters. I'm going to write this a little bit neater. Your parameters will be different. And when I say parameters, I am talking about your metric of analyzing your problem, or your metric of analysis. Okay, what are you taking into account for the types of equations you're going to create to solve the type of problem that you're addressing, right? Are you going to take into account materials, how the materials were used or the systems were used? Or are you going to take into account and create different types of equations that deals with a variety of different types of variables that makes the problem or the solution to your problem a lot more form-fitting and very specific, right? So this is something to keep in mind. So, all right, going back to the questions that I had posed to you in the beginning, where we have defined the problem, we have analyzed the problem. Around this step, this is what I would like to usually do. I would like to model what I plan to do, what's going on, and potentially what is going to happen, which will typically happen around the problem solving step once you've fully established your metrics of addressing the problem. So this is all addressing the problem side of things, right? This is where the problem is. So an example of this may be, right? You say you were given a task to create or make something, like make a cake. You were told, okay, make a cake. What's the problem? Or the task that you have to do, right? The problem doesn't necessarily have to be negative in terms of connotation. Maybe you're told to, let's say, make a cake. And then you were to analyze the task. You would have to first ask yourself, what do I need to make the cake with? Where do I make it? And how long is it going to take? Based on certain types of other questions you should be asking, like, is this for an event? Is this for a personal thing? Is this for whatever type of situation? Where are you going to do it? Maybe you may or may not have access to a kitchen. And what are you going to use to make the cake with? And another thing for the how is whether or not you're experienced enough to make the cake. So once we've defined the problem and we've analyzed the problem, the modeling section will look a little something like this. You can do 3 sections where you could say, okay, what's going to happen before, right? Typically in the before stages, you would do prep work. You would prep and gather your materials. You would create a list of instructions in your head or whatever to say, okay, this is how I'm going to make the cake. And then you go from there. And then this is the present, or the creation stage, or the implementation stage. And this is where you take all the items and the list of instructions and you follow the list of instructions and you implement it. And you just go through each of the things. And then after that is the final stage, where you prep everything and you check your work to see if your solution is correct. Or in this case, you get the result of the cake. Is it a cake? Does it pass certain types of parameters, like does it taste good? Is it safe? Does it even look like a cake? Does it even taste like a cake? Taste like a cake? And more so on the look thing as well, what's the presentation of the cake? What type of icing did you use for the cake? What is the ratio of ingredients to make the cake? Is it all well balanced? Is it harmonious? So it's something to consider. Yep, I'm going to keep saying that a bunch of times in this video. But that is life in terms of dealing with problem solving. So I would hope that you're seeing the importance and the significance of looking at problem solving and using that as a tool set and a skill set to go into any endeavor. And what am I trying to say? It should be something that you have in the back of your head and should be something that you're doing on autopilot. That way you're efficient with your time. You're able to complete any task that you could do. And you're able to see which parts of the process that you need to alter to make sure that you get the desired results, right? So once we delve into these steps, the next thing would then be to solve. What does this look like? This looks like kind of like with the modeling stage over here. You want to start with devising and writing out your lists of options or potential solutions to choose from. After examining the nature of the problem, you then go through each of the different solutions that you have or don't have and see which is most appropriate. So you perform as what we like to call a riot check for each of the following solutions. Right? You need to go through the list. And then once that's done, you make a choice. Based on the nature of the problem that you were told in any type of situation, and going through the list of solutions to solve problems like this, and seeing which is the most efficient one, you want to narrow it down to ideally one solution to solve for a problem. Because that's all it takes to solve a problem, right? And depending on the problem, it may have more than one solution. And at that point, it really is up to you to choose a way to solve the problem. So once you make that choice, you then solve the problem, which comes from, again, implementation. And going through the problem step by step to see you check off everything, you follow the steps, and then afterwards, you check your work. You have to forgive me also too, my handwriting is terrible because I'm trying to get my ideas out, and my mind's moving a little bit too fast for my body to keep up. So, check your work. And if it passes, it passes. If it don't, just go back to the drawing board. And if you need to, just go back to the problem solving steps. And I can guarantee you this much. When it comes to dealing with any type of problem like these, a lot of the different types of businesses that ended up being successful or endeavors have some type of systematic approach that delves with defining what your problem is, or area or niche that you want to focus on, and modeling how you want to get it done, and actually solving it. Like I said before, you can't have one without the other. So I leave that with you to consider and to think about. And yeah, that's it. Be easy.